All right, guys, today's topic is going to be exponential functions. Now, the last class, we saw what were rational functions, right? Rational functions. Now, today we're going to see another type of function. We have been seeing a couple, right? So far we know what are linear functions and quadratic functions and also another type of polynomial functions, right? Cubic functions and all of that. And we also saw rational functions, all right? A lot of functions. Ninth grade can be just the, the course of functions. You know what I mean? All right. Today we have another function, the exponential function. Now, maybe this is probably the most important type of function that you are going to learn. No matter what you're going to study in your future, you are most likely going to have to use this at least once or twice. All right. So let's begin with the easiest. Let's do just one example here. Let's try to read this. All right. Let's try to read this. Go ahead and try. Give it a try. Read it yourself. Go ahead and give it a try. Read it yourself. Go ahead and give it a try. Right? Did you get the idea? All right, cool. So this guy, John, the guy is new to Instagram, right? And the guy wants to have more likes and more comments, right? Now, he is going to get more followers in following some steps. He's going to follow some steps. In the first step, he's going to get 2 new followers, right? He's going to get 2 new followers. And then those 2 new followers must each get 2 new followers. Each need to get 2 new followers. All right? Then each of those new followers are going to get 2 new followers and so on. Right? Samuel Rodriguez, a Cata se le fue la luz. No! Thank you, Samuel. Thank you for letting me know. Thank you. All right, so let's take a look at this. This is going to be the table, right? The table. So at the beginning, he's going to get 1 follower, right? And that follower is going to get 2 new followers, right? Then the question is, how can we figure out the number of new friends for any step? Right? That is the question. So for the second step, how many followers there? And for the third step, how many followers? We can just do this, right? We know that each new follower is gonna get 2 new followers, right? So if we have 2 here, these 2 are gonna get each 2 new followers, right? So we get 2 in here. We get 4. 2 times 2, right? And for these 4, each of these 4 followers are gonna get 2 new followers, right? So we're doing 4 times 2 again. That is 8. Did you get it? Are you following this or not? All right, cool. Now, for the 4th step, how many followers do you think the guy is gonna have? Write it in the chat, please. How many followers do you think the guy is gonna have? Carol Andrea, hi, mister. I have internet issues, but I am here. All right, Carol, thank you for letting me know. Thank you. Guys, I appreciate those of you who are answering. Thank you. Remember, you're not going to learn unless you practice. Thank you, guys. Wow. We have a lot of answers today. Thank you. Thank you, guys. All right, pretty good. Pretty good. So, yes, you guys are correct. All you have to do is do 8 times 2. So, 16 new followers, right? 16 new followers. Right? That is what we have here. Notice that we multiplied the same number in each step. In this case, we multiplied the number 2 in each step. Right? So for the next one, we can do 16 times 2. That is 32. But the question, guys, the question. How can we do this for the step 20? How can we do this for the step 20? Huh? So we will have to continue this, right? We will have to keep expanding this all the way until 20, right? Well, that takes a lot of time. That takes a lot of time. So why don't we just use an exponential function? Take a look at this. Take a look at this function. Take a look at this function. Let me just new. This is going to be our new function. New friends equals 2x. Look at this. If I replace the number 1 for x, so x equals 1, how much is new friends? Well, 2 to the 1, right? And 2 to the 1 equals 2. Look at that. For step 1, new followers equals 2. So this function is going to give us the result without having to do every single step. Let me show it again. Let me show it again. Let me just erase all of this. Show it again. La, 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 la. Let's say that we want x to be 5. X equals 5. Now, we know that the result is 32 new followers. We know that. But if we just use the function 2 to the 5, it's going to be 32. So this function, why is this function useful? Because just knowing the function is going to give us the result without having to do every step before. Paso un momentico al español. Si no les hubiera yo dado, si yo les pongo así nada más, sin mostrarles el paso anterior al 32, pues es más difícil que saquen esto, ¿cierto? Por ejemplo, para 20, ¿cuántos seguidores serán? ¿Cuántos? Este tipo lo hizo, Nicolás Parra lo hizo. Muy bien, papá. Pero el hombre, o sea, de pronto se puede hacer de dos maneras. Mira, puede uno seguir expandiendo, ¿no? De 32 por 2 y eso daría el sexto step. Y luego eso por 2 y eso me daría el séptimo step. Y luego eso por 2 y eso me daría el octavo step. Y así, hasta llegar al 20. Esa es una opción, pero es muy larga. Pero si solo usas la función, puedes reemplazar x por 20. Eso sería 2 a la 20. Y sería, bueno, un valor que no sé cuánto es.
El que ya puse, profe.
Yes, Nico Parra and Tefa Cabrera, you guys are correct. Both of you are correct. This is 1,048,576. If you want to take a look at the number, you just go and take a look at the chat. It is right there. All right, guys, congratulations. Beautiful, right? So that is the idea behind an exponential function. Take a look at this. This is the definition. An exponential function is a function of the form f of x equals z times ax, a to the x, right? Take a look at this. This c and a, these two letters, c and a, are numbers. A is a positive real number and c is also a positive real number. Now, those two numbers have one characteristic. The first one is that a, so this number in here, cannot be 1. It can be anything else, but it cannot be 1. And also, this value here, the c, cannot be 0. It can be anything else, but it cannot be 0. All right? So let's take a look at some examples of exponential functions. Oh, by the way, these numbers have names, right? Take a look. The a is called the growth factor. Danny, here. Buddy, pay attention, please. Right, a is the growth factor, all right? The growth factor. So maybe in one example, I say, write down the exponential function with a growth factor of 3. So you know the a equals 3. A is called the growth factor. Go ahead and write it down, please. And also c is called the initial value. The initial value. Sometimes it is also called the principal. Principal value, initial value, that sort of thing, all right? So we have two things, growth factor and initial value, because we have two numbers, growth factor and initial value. right, take a look at this. Here are some examples of exponential functions. These are examples of exponential functions. Guys, please tell me what is the growth factor in the function f? In the chat, please take a look at the function f. So this one in here, the one that I'm showing you right now with my mouse. This one. This is the function f, right? 2 to the x. What is the growth factor? What is the growth factor? In the chat, please. Now, in case you don't remember, a is the growth factor. So is this value here. Is the one that is being elevated to the x. The one value that is being elevated to the x. That is the growth factor. So what is the growth factor in our function f? Okay, a lot of you are participating today. Cool, pretty good. Thank you, guys. Man, I don't know what's going on with you today, but keep it up. I love it when you guys practice. I love it when you guys answer my questions. Thank you. You guys are correct. You guys are correct. 2 is the growth factor. The growth factor here is 2. Now, sometimes we call that value the base. So it is the same value. Just write it down as the growth factor or the base. It is the same value. It's the one that is being elevated to the x. All right? That is the growth factor. Sometimes the base. So the base is 2, or here the growth factor is 2. All right? Question. Quick question. And this one is a little bit hard. But don't get scared. All right. You guys remember that here I said that c was the initial value, right? C is the number that is multiplying ax. So the number that is multiplying the growth factor. In our case, the growth factor is 2. But what number is multiplying 2? In other words, find the initial value. Please, in the chat, find the initial value. And you guys are on fire today. Look at that. You guys are on fire today. Beautiful. You guys are correct. The initial value is 1. Why? Because here, we can see that there is a 1 there multiplying the 2. Now, of course, the 1 wasn't there, right? I just put it there because there is nothing there. And remember, when there is nothing, that means there is a 1. That is the initial value, guys. That is the initial value. Congratulations. All right. In the same way, we can say that the base of the function g is 10 and the base of the function h is 3. Again, base is just another name for the word growth factor, right? The growth factor here is 10 and the growth factor here is 3. Some of you might be saying, but teacher, look at this. This exponent is weird. What is this exponent? All right, don't get scared. That is just a weird exponent, right? That is just a weird exponent, but it is also an exponent. X plus 1 can be an exponent, right? So even if in the exponent you don't have an x, maybe in the exponent you have x plus 1, when that happens, that's still a good exponential function. And the 3 is still the same growth factor. By the way, each and every one of these functions have an initial value of 1. All right, cool. How did you find the values of the function when we replace? So take a look at this. What is the value of f of x when when x equals 2? Yes. What we do is just replace the values of x by 2. So look at this. Instead of x, we're going to write down a 2. So what that means is that instead of doing 3 to the x, we're going to do 3 to the 2. That means replacing the value, evaluating. Otra vez vuelvo y lo repito en españolito. Eso significa evaluar la función. Cuando en el examen, o en el taller, o en el cuestionario, o cuando sea, les pregunten, evalúe la función cuando x valga tanto, pues no es sino cambiar el valor de x por tanto. Again, this is called evaluating the function. Evaluating the function. So here we just evaluated the function when x equals 2. And the result is 9 because 3 to the 2 is 9. Let's do this one now. Let's evaluate the function when x equals negative 2. How much is this? Negative 2. All right, so we have this, right? F of negative 2 equals 3 to the negative 2. Oh, but I don't know what to do with negative exponents, teacher. It's okay. All you have to do is remember your properties of exponents. You know that if the exponent is negative, you can change that into a root, into a fractionary, right? You can change that into a fractionary. So this will be equal to 1 over 3 to the 2. With the opposite sign. Look, here was the negative sign. Here is the opposite sign. The negative, the positive. Did you see? Here we have negative. Here we have positive. Right? You can do that. That is one of the rules or of the properties of exponents. Do you guys remember this or not? Well, hopefully you do, right? Now, how much is this? How much is this? Well, this is 1 over 3 to the 2, and we know 3 to the 2 is 9. So this is exactly 1 over 9. Of course, if you have your calculator, you can round this, approximate this to a decimal. This is 0 point something, right? Maybe 0.1. Let's say 0.111, right? So you can do an approximation, but remember, this is extremely important, guys. This is the real answer. This is the real answer, and this is an approximation. So, if I give you a quiz, guys, all right, guys, Danny and everybody, please. If I give you a quiz and I ask you how much is 3 to the negative 2, and I say, find the real answer, and you say the real answer is this, because this is what the calculator gave you, then you have a mistake. Déjeme ser claro otra vez. Poner lo que la calculadora dio no significa que esté bien. Si ponen que la respuesta real es 0.111, está mal. Eso es una aproximación. Ahora, claro, ustedes pueden decir, profe, es que no es, miren, la calculadora la respuesta no es esa. La calculadora la respuesta es 0.1111111. Me faltaron unos unos. No. Esto es todavía una aproximación. La respuesta real sigue siendo esta de acá. Si les pregunto por la respuesta real, tienen que escribirme esta de acá, el fraccionario. Si les pregunto por el redondeo, por la aproximada, ahora sí pueden anotar esta. All right, guys, did you get it or not? All right, cool. So let's continue evaluating our functions. What is the value of this? The value of g, the function g. 0.5 to the x. We are going to evaluate the function when x equals 4. Now, guys, please, in the chat, go ahead and find the approximated answer. Approximated. Tell me in the chat, please, everybody. Give it a try. All you have to do is use your calculator. Give it a try, all right? How much is the value of g of x when x equals 4? So evaluate the function, please. Evaluate the function. In the chat, please. Don't forget to write down your answer in the chat. All right, okay. Whoa, look at that, guys. Thank you. Man, all of you are on fire today. Sure, this is just proper use of calculators, sure, but I love it when you guys practice. This is the correct answer. Beautiful. All we have to do is replace the value of x by 4. Then we're going to have 0.5 to the 4. That is 0.0625. Beautiful. Beautiful, guys. Thank you. All right. This is called evaluating a function. This is what it means to evaluate a function. All right. Let's talk about the graph of exponential functions. Remember, so far we have what is an exponential function, right? We have some examples. We know now how to evaluate it. And let's talk about what is the graph. How do you graph this thing? Right. So take a look at this. When you graph, you can have two cases. You can have an exponential growth or an exponential decay. Growth means the values of the results are going to be increasing. Look at this. When x equals 0, the function equals 3. When x equals 1, the function equals 15. Look at this. The function just increased. It went up. The value is bigger. Same with x equals 2. The value is even bigger. It's 75. It's even bigger. When x equals 3, the function is a lot bigger, 375. As you can see, guys, the value of the function is increasing. This is called exponential growth. Go ahead and write it down, please. Exponential growth means the function is increasing, going up. All right? Just like you can have the values going up, you can also have the values going down. That is called exponential decay. Decay. We have exponential growth and exponential decay. Look, exponential decay. Look, take a look at this example. When x equals 0, the value of the function is 32. It's a relatively big value. When x equals 1, the value is 16. So it is smaller. It is going down. When x equals 2, the function equals 8. Now it is going even lower. And when x equals 3, the function equals 4. So look at this. The values of the functions are going down. This is exponential decay. We have exponential growth when the function is increasing, and we have exponential decay when the function is decreasing. All right? But also take a look at this, guys. Take a look at this. The function, did you guys remember the form of the function? C a to the x. C a to the x, right? Whenever the value of a is bigger than 1, so in this case, for example, take a look. The value of a in this case is 5, right? The growth factor is 5. So in every step, we are going to have an increase of 5. In every step, we're going to have an increase of 5. That is why the function is going to increase, because the exponential, sorry, how do you call this value now? The growth factor, forgot the name, because the growth factor here, the value of a, is bigger than 1. Bigger than 1. In this case, it's 5. So we have exponential growth, right? But in this case, look, in this case, the value of a, so the exponential growth, is lower than 1. It is lower. Look, it is 1 over 2. If you put this in a calculator, 1 over 2 is 0.5. So 0.5 is lower than 1. Again, the value of a, the exponential growth, the growth factor is lower than 1. So in that case, we have exponential decay. All right, guys, this is extremely important. Hopefully you guys are taking notes, right? Hopefully. All right, but how do the graphs of this look like? All right, the function of the graph of the first one looks like this, and the graph of the second one looks like that. Look, for exponential growth, every value of the function is going up. So it makes sense that the function increases from left to right. From left to right, right? So look at this. The line is going to go up. Of course, some of you might say, teacher, but if I look at the function from right to left, look, the line goes down, teacher. The line goes down. Yes, you are correct. But that is why we have to look at the function always from left to right, de izquierda a derecha, desde los negativos a los positivos. Left to right. In that case, look, the behavior of the line is going to go up. This means we have an increasing value, an exponential growth. And if we take a look at the other function, look at this. Again, from left to right, the function is very big, and now it is going down. It is decreasing in value. The function is decreasing in value. So that is called exponential decay. All right? Beautiful, guys. So we have three ways of finding exponential growth or exponential decay. Now, number one, we can take a look at the values. If the values are increasing, we have exponential growth. If the values are decreasing, we have exponential decay. But also, we can take a look at the value of a in the function itself. If the value of a is bigger than 1, we have exponential growth. If the value of a is lower than 1, we have exponential decay. That is the second way. But also, we have a third way, and that is looking at a graph. If the line goes up, then we have exponential growth. If the line goes down, then we have exponential decay. Beautiful, guys. Look at that. We are running today. All right. Let's jump into the big deal, into today's big deal. Everybody needs your calculator for this. Everybody needs their calculators for this, right? Modeling functions. This is the topic that I was telling you about. This is extremely important. Again, it doesn't matter if you're going to study in 10th grade analysis or applications. Remember, for your IB subjects, you can choose two, right? For math, you can choose two. You can either choose analysis or you can choose application in mathematics. Either way, no matter which one do you choose, you are going to have to see how to model a function. And I'm going to teach you that right now. So let's take a look at this example. In here, I have a table of data. We have values for x and values for f of x. This is some data, right? When x equals -3, the function is going to be 8. When x equals -2, the function will be 4. When x equals -1, the function will be 1. 0 will be 1. 1 will be 0.5, and so on. We have our list of data. So let's begin by what does it mean to model a function? Here it is. Modeling a function means to find the function that best fits the data. That is the idea behind modeling. Find an equation for all of these data. That's it. That is it, guys. Finding an equation that best fits all of this data. All right? But how do you do that, guys? How do you find that function? How do you find that equation? With your calculator. Of course, there are a ton of ways to do this without using the calculator. But number one, it's going to take you an incredible amount of time. A couple of days. 40-some hours. And also, doing this without a calculator requires you to know mathematics that you don't know so far, right? But the use of calculator is pretty simple. So that is what I'm going to teach you now. All right. Let's start with our example. Do you have your calculator with you, guys? If you don't, please find it. Go get it. You need it for today. Let me open my calculator as well. I need to show you how in my calculator. Ah, qué rico agüita. Uy, una agüita. Okay. Here is my calculator, guys. All right, there it is. Beautiful. So how do you do it? Let's begin with some steps. Number one, the first step, we're going to plot these points. Now, you can plot the points in a piece of paper. But we have the calculator. We're not going to use a piece of paper, guys. We are going to use our calculator. So let's go our calculator, right? Let's go to our calculator and let's plot these points. To plot the points, we need to first enter the points in the calculator. So we're going to press the key stat. Stat means statistics. That is what we're going to do today. We're going to do statistics. You guys are following me here or not? Good. Thank you, Tefa.
Yes.
Thank you.
Yes, mister.
Thank you, Nico. All right. So we press stat, right? And look at that. We can edit the data, we can calculate, or we can run some tests. So far, we want to edit the data. That's the first thing we want to do. We want to edit. So you just press enter. Make sure you are on edit. There it is. Now, if you have used this in the past, like me, then you have some data already. You can erase that. How? Simply clearly. Press clear and enter. There it is. Clear and enter. And that's it. You cleared the data. That is it, guys. Thank you, Yankita, for answering the question. Thank you. All right, let's take a look at our data. Here it is. So in the first list, we're going to write down the values of x. And in the second list, we're going to write down the values of f of x. So let's do it little by little. So -3, -2, -1, 0, 1, 2, and 3. Right? And I have the values of the x in the list number 1. For the second list, I am going to pass to list 2. And all I have to do here is just write down the values. So I have 8, 4, 2, 1, 0.5, 0.25, and 0.125. All right? That is the first step, guys. Let me know when you finish. Guys, everybody, please, in the chat, if you finish doing this step, write down, I finished, or write down, done, teacher, something like that. Let me know that you finished. Done, done, done. I finished, done, done, done. Okay, man, I feel like you guys are faster than me. All right. Okay, so remember, we are plotting the points, right? That is what we're doing. We're plotting the points. So far, we haven't plotted anything. So far, we haven't plotted anything at all. We just introduced the data in the calculator. So let's plot it. Look, we can press graph, and that is not going to help us because we don't have a function to graph. We need to do a statistic plot here. Did you see the the blue word, statistic plot, on top of the Y key? Press that one. So second, Y. Statistics plots, right? From here, we can press the first one, enter, right? And we need to make sure it is on. I have it on off because I was not using statistic plots. I was not using statistic plots. So I have it on off. So I just need to move on to on and press enter. Look at that. Now it is on. Right? Now we need to find out what is the type of function we want. Look, this is what you should get in your calculator. We have this type of function. This is called a scatter plot, right? You know that. You know what a scatter plot is, right? Or we have a line graph, right? This is the line graph. Or we also have a histogram or a box and whiskers, maybe another box and whiskers, right? We have a lot of data. We have a lot of types of functions. Now, for this specific case, we want to plot the data as a scatter plot. So we want the first type. You just press enter and there you go. We are good to go, right? Now, let's move to X list. This part means the list in where you put the values X. In my case, I put it in list 1. Remember, I said to put it in list 1 and the values of f of x in list 2. Remember that? Okay, so I'm going to say list 1 here and list 2. In case maybe I change it because I was a rebel and I want to put the values in X in list 3. How did you change the list? Here. You can find the names of the list in here. In the blue names on top of the keys. Look, list 1, list 2, list 3. So let's say I can do second 3, and all I did was change it to list 3. In my case, I want to have it for list 1. So I just do this. I know, let's erase. Second 1, list 1, and the values of y, list 2. This doesn't really matter. The mark doesn't matter. The color doesn't matter, right? From here, what do? Now we press graph. And look at that. If you're like me, you have this function in here, but that function should not happen. Let me just erase that. Clear. Then graph. Beautiful. This is the result. Just a bunch of dots, right? Mira, la razón por la que me apareció la linecita continua es porque esa era la función que teníamos aquí. En y igual, esa era la función que teníamos. Pues lo único que hice fue borrarla. Y ahora sí ya no me apareció. Ahora solo me aparecen los punticos. Each and every one of these little dots that you can find here are points in our data. So look, the point negative 3,8 is this one. Negative 3,8. How about that? Now, if you cannot see the points, it could happen for a couple of reasons. Number one, maybe when you were editing the data, you didn't do it with this negative. You do it with this negative. That is a mistake, right? This is negative, this is minus. You don't do it with this. You don't press this minus, you press this negative. Right? Creo que cuando eso pasa, les aparece que hay un error de sintaxis. If you get syntax error, then maybe that is the reason. All you have to do is go back to statistic, edit the data, and don't write it with this negative, write it with this negative, right? Also, maybe you cannot see the points like this because you don't have the same window that I have. Look at my window. If I press the window key, these are the values that I have. You can change the values to have some different values. I'm going to change the values to have more accurate values for this. Look, in my example, x goes from negative 3 to 3. So I can do that. Let's say negative 3 to 3. I want on a scale of 1 because I want to have the little line separated by 1. And in the y-axis, I want to have a minimum of 8. I'm sorry, a minimum of 0.125 because this is the minimum, and a maximum of 8. So I'm just going to write that down. 0.125 and a maximum of 8. Again, I want on a scale of 1. Once I've done that, I press graph. And now look at this. Now we can see the points even better. Even better. How about that, guys? Huh?
Profe, ¿lo puede poner otra vez, porfa?
Sure. What part? What?
Window, porfa.
Window, sure. There it is. This is not negative 1.5. No, this is not negative 1.5. This is 0.125, right? Pero mira, tengo que ser claro en esto, muchachos. Si paso al español aquí es para que me entiendan y me quede clarito, ¿listo? Estos valores no son necesarios para que se vea para que aparezca la función. Pueden poner otros valores. Mira, voy a poner otros. ¿Por qué? Pues porque, ¿por qué no? Negativo 5, hasta en X pongamos hasta 5, una escala de 1. Y en Y pongamos desde 0, ¿sabes qué? Desde negativo 1, pongamos, ¿por qué no? Hasta, ay, madre, la embarré. Go to. Ese era el negativo. Negativo 1 hasta el máximo que digamos quiero 10. Una escala de 1. Ahora sí, graficar. Mira. Cambia mi ventana, pero los puntos siguen igual. ¿Cuál es la importancia de elegir la ventana? Pues que se vean los puntitos. Y uno elige una ventana que le guste a uno. Una ventana con la que uno esté cómodo. Si esta ventana que acabé de hacer les gusta más, pues entonces la dejan así. Si les gusta otros valores, pues los cambian. La importancia de esto, mis niños, es que ustedes se sientan cómodos. ¿Ok? All right, let's continue. So let's come back to our steps. First step, plot the points. All right. We have it there. We have plot the points. All right. We have plot the points, guys. Congratulations. We have plot the points. All right. Well, what do we do now? Second step, analyze the behavior. Analyze the what? What is this thing? How do you analyze the behavior? Okay. Analyzing the behavior means to take a look at the graph, take a look at the points, and think about a possible function for these points. Think about a possible option for these points. Let's do an example. Let's erase all of these. Let's just do an example. So let's say in my plane, I have this data. These are the data that I have in my plane. That is the data, right? Analyzing the behavior means to think about a possible function. Now, we know a couple of functions that we have studied in the past, I'm going to write those types of functions in here. We have, first, we have linear functions. Second, we have quadratic functions. Third, we have any type of polynomial, right? So cubic functions, or maybe quartic functions, quartic functions, right? We also know rational functions. And last, the one that we have seen today, exponential functions. Analyzing the behavior means choosing one of these. That is what it means, choosing one of these that better fits the points. Now, guys, please, this step is the hardest of modeling a function. This step number 2, analyze the behavior, is the hardest. All right, is the one in which we can make mistakes. So don't get scared if you make a mistake right now. It is okay to make mistakes. I want everybody in the chat, please, everybody in the chat, write down, what do you think is the best type of function for these points? For these ones in here, the ones that I'm showing right now. So write down the word linear if you think a line is the best fit. Write down the word quadratic if you think a quadratic function is the best fit. The cubic, write down the word exponential, for example, if you think an exponential function is the best fit. And don't get scared, right? I know it could be scary, but don't get scared. I'm not gonna read the answers, all right? Don't get scared, guys. Ooh, okay, a lot of you already answered, okay. Wow, all right, guys, wow, all right, cool. Beautiful. Okay, a lot of you are saying linear. You know what, guys? You know what? I would also say linear, because I think if I just trace a line, I would get most of the points. Look at that. Of course, I didn't get all of the points. Of course, I didn't get all of the points. And that is going to happen sometimes. Sometimes we don't get all of the points. That is why we are looking for a best fit. A best fit. The line that best fits all of the points. Look at this. I am missing a couple of points here. I am missing this point here. I am also missing this. I miss these points. But it doesn't matter. I assured you. Look, I assured you. If I would have drawn a different line, so for example, if I would have done an quadratic line, I could have had something like this. Oh, no. Let me do it with red. That is not a best fit, right? I missed a lot more points. This one, I missed a lot of points there. So the linear was better. Sure, in the linear, I missed a couple of points. but I'm missing less than if I do it as quadratic. And the same goes for cubic. I could have done cubic. Look, this could have been a cubic function. You know what? A cubic function is even better than a quadratic. But again, I am missing a couple of points. I'm missing this. I think a linear is a better choice. That is what it means to analyze the behavior. Analyzing the behavior is thinking about which of these options is the best. All right. So let's analyze this behavior, the one for the calculator. Which one do you think is the best option? Again, remember, one of these three, one of these. Linear, quadratic, cubic, quartic, rational, or exponential. Go ahead and write it down in the chat, please. Which one do you think is the best option? Write it down in the chat, please. Don't be afraid of having mistakes, guys. Okay, we have 2 people answering so far. We have 2 people answering. It's okay to have mistakes, right? So you might be thinking, I don't know, quadratic? Okay, it's okay. Just tell me what you think it is, all right? Doesn't matter. Don't believe the first person who answered, because that person could have a mistake. You write what you think, guys. You write what you think, all right? Maybe you're thinking, I don't know, teacher, it looks like an exponential. Okay, so just write down exponential. Write down what you think, guys. What you think. Okay, we have 13 answers. Beautiful. That is a lot of people. All right, all right. And a lot of you are saying exponentials. We also have some people saying that this could be a quadratic. All right. Let's take a look at these. Okay, so this could be something like this, right? If I join the points, it could be something like that. Now, of course, I could continue the drawing like this, and that could be a quadratic function, right? So the people who said quadratic, that could be it, guys. That could be it. The people who said exponential, you know what, guys? Exponential function will be something like this, and then continuing like this and like that. I know. Like that. You know what, guys? Exponential function could also be. So analyzing the behavior sometimes can give us multiple answers. It can sometimes give us multiple answers. How do we know for sure? How do we know for sure? Aquí solo hay un consejo que les puedo dar, mis niños. ¿Sabemos segurito cuál es el tipo de función? Entre más ejercicios nos hagamos. ¿Ok? Entre más ejercicios nos hagamos y más veamos el tipo de función que es, mejor nos vamos a volver y más cercanos nos vamos a ir aproximando a un buen análisis. En este caso yo diría que es una exponencial. El profesor Gustavo diría es una exponencial. Yo tengo un poquito de experiencia en esto y se me hace que es más parecida a una exponencial. Siento que si fuese cuadrática, los punticos irían como así, mira, como esos aquí, pero luego este otro punto iría como aquí, perdón, ya me borro. Este otro punto iría como, a ver, como aquí, como aquí, como aquí, como aquí. Si los puntos fueran más inclinaditos, ahí sería una cuadrática. ¿Listo? Yo diría eso ya es basado en mi experiencia. ¿Ok? ¿Cómo adquieren ustedes una buena experiencia? Bueno, pues haciendo ejercicios. Otra cosa que ayuda muchísimo es tener más datos. Look, we only have 1, 2, 3, 4, 5, 6, 7 data in here. 7 data. We only have 7 data. So if we had more data, then it would be easier to know the behavior of the dots. But we only have 7. So the more data we have, the easier analyzing the data, analyzing the behavior, becomes. All right. Cool. So let's say this data behaves in an exponential way. Let's say it behaves in an exponential. So now let's calculate the regression. Ooh. This is the third and final step, guys. And again, it is done using the calculator. So we know so far, we know that the function we have chosen is exponential function, right? So we want to do an exponential regression. A regression means to find the function. That is what it means. So we are about to find the function for this data. The final step. Find the function. Now, if we have said that this data behaved in a line, again, it clearly doesn't behave in a line, right? It clearly doesn't behave in a line. But let's assume for a minute, let's assume that it did behave in a line. We could do a linear regression, right? Maybe if we had said that these points behave in a quadratic behavior, maybe we could have done a quadratic regression. Each regression depends on the analysis that we did. We can do a linear regression, quadratic regression, cubic, quartic regression, rational regression, exponential regression, and so many more regressions. And all of those can be done in the calculator. This is how, guys. This is how. Again, we are going to go to statistics, right? So in your calculator, press the statistics button here, statistics. And look at this. We are going to calculate the regression. So we just, instead of being in the pestaña, how do you say that? Well, whatever. Instead of being in this option, edit, you're going to move to calculate. Calculate, right? In here, we can calculate a lot of things, but we want the regressions. You can find those regressions like this, the word reg. So look at that. If I go to option number 4, we can find the lin reg. That is the linear regression. If we move a little bit down, we find the quad reg, quadratic regression. A little bit down, cubic reg. You see, cubic reg, the cubic regression. Quart reg, quartic, quartic regression. But the one, what is that? What is it that we want, guys? What is it the one that we're looking for? We are looking for exponential regression, right? So let's go a little bit down. No, we don't have more options. More. Look at that. The option 0, exponential regression. Look, exp reg. So that is what we are going to do. Enter. Exponential regression. And now you should have this screen. In this screen, the calculator is going to ask you to write down the X list and the Y list. Again, for X list and Y list, we are talking about this list of data. This one and this one. Did you guys remember where did you write it down? We write it down in list 1 for X and in list 2 for Y. You guys remember this or not? All right, cool. All right. That is all you have to do. That is all you have to do. Now, we also wanted to tell us what is the function, but we want the calculator to store it somewhere, to remember that function, right? So what we're going to do is, how is it that we do it here? No. We wanted to store it, but I don't remember how to store it. List, second list. Nope. Variable maybe. I don't remember. Draw angle test link. I just don't remember. Nope. I forgot about that. Second, enter. Nope. There is a way to tell the calculator to write it down somewhere. Nope, it is not that way. Calculate. Give me just 1 second, guys. Exponential regression. This one, this two. Store, man, where did you put that? There was a way, but I don't see it here. Store? Nope. Whatever, we couldn't. I forgot how to do it, guys. I forgot how to do it, guys. Sorry. List. Statistics, sorry. I forgot how to do it. I know. Quartic regression, no. Oh. I just zero. Exponential regression. All right. Bueno, paso un momentico al español. Aquí lo que estaba buscando era una forma de decirle a la calculadora que me guardara la función que vamos a encontrar. Y uno la puede guardar aquí, en Store Regression. Pero no me acuerdo cómo. No me acuerdo cómo. No me acuerdo cómo. Había una forma, Ala. Ah, qué triste. Second links. No. No me acuerdo cómo. Bueno, entonces va a tocar que la anotemos a la mala. A la futuro, cuando sepa cómo es, les digo, ¿listo? Para no tener que hacer eso. 0, exponential regression. All right, so going back. So let's come back to this example. So we have list 1, the X list, list 2, the Y list, right? All we have to do now is press calculate. Look at this. After a while, the calculator is thinking, and after a while, the calculator is going to give us a function. It's going to give us some values. And we need to make sure we write down these values properly. Look. This is the form of the function. A times B elevated to the X. This is the form of the function. So this function means the function is y equals A times B to the X, right? That is the form of the function. But the calculator is also telling us what is the value of A and what is the value of B.
Hey, teacher, I plotted in my calculator, but it don't give me the R's.
Doesn't matter, Danny, doesn't matter. The R's are for some other thing that we're not using today.
Oh, okay.
Okay, sure. The R's, the R square and the R alone are useful things, but those doesn't matter for what we are doing today. Those don't matter. All right. So let's write down the proper function. The proper function will be A, which is 1, so 1, times B, so times 0.5 to the X. That is our function. Of course, we don't do points in mathematics for multiplications. We do parentheses. So we have 1 times 0.5 to the X. That is going to be our function, guys. That is going to be our function. Of course, in this specific case, we don't have to do the 1. We can just do 0.5 to the X. Because multiplying by 1 doesn't matter, right? Doesn't change anything. So this could be the function. And this is the idea of modeling. Remember, we were, again, let me come back a little bit more. We're modeling the function, right? Modeling a function means finding the function that best fits the data. So the equation, after all of these steps, now we have our function. 0.5 to the X. to the X. Why did we do that? Okay, well, because we can use it to do some other things. We can use it to predict values, or we can use it to find values in between. It depends on the question, all right? Today, you guys are going to practice on a lot of questions, a lot. By the way, if you want to write down this function, so you can do just this y equal, And in here, you can just write down the function. So the function was 0.5 elevated to the x, right? 0.5 to the x. Are you looking at what I'm doing? 0.5 to the x. If I press graph, look at what's going to happen. Look at what's going to happen. Look. The function passes to most points. In this case, we did such an incredible job that the function, the line, passes through every point. Look at that, through every point. Wow. Our function is pretty good. Our function is really, really good. All right. We just found the model. Beautiful, guys. Hopefully you guys don't forget about what is modeling because you're going to use it today a lot. Let's jump into some exercises. Page 432, exercises 15 to 40. Now, of course, these are for the old book. You guys have the new version. So, I don't know what is the patient, what are the exercises. But hopefully our assistant, Tefa, who always help us with this, is going to write down in the chat anytime now the real exercise and the real pace, right? Anytime now. Anytime now. No, she's doing it. She's doing it. I can see it. I can see her. She's doing it. She's doing it. Thank you, Tefa. You're so kind, Tefa. Thank you. Are you guys ready? You guys ready? She's about to do it.
Profe, pero ¿y si muestras cuáles son los que aparecen para que busque?
Okay. Listo. Okay. Let me open the book because I don't have it here. The book. Just open the book. The book. I'm about to open the book. La la la. The book doesn't want to open. La 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 la. I don't know why it's not opening. Please, book, open. Please. Book. Guys, it looks like I cannot show you the exercises. My book doesn't want to open. I don't know what's going on. I have no idea what is going on. Please, book, please. All right, give me a couple of minutes, guys. I don't know what's going on. Y justo hoy, ala, qué triste. Uy. ¿Puede abrir, por favor? Ahí está, bien. All right. 400 what? $432. Okay. These are the exercises, guys. Wish. From 15, but to 40. All right? We have a lot of functions. And look at this. All of these required you to model. All of these required you to model, guys. So this is why I explained it today. I need you to just model these guys. Begin with this, 15 to 24. And when you are done with those, jump into this, modeling. And when you are done with those, jump into this. This is just graphing in your calculator. You can just graph with this. It doesn't really matter. All the way up until 40. All right, guys, I'm going to stop the recording here. Remember, if you have any doubts, I am here for you. let's get to work.
Profe, ¿puedes mostrar los primeros ejercicios, por favor?
Of course, Stefa, of course. Right, there it is. And I'm gonna start recording now.